So we're going to learn about the new topic, that is data structure and algorithms. So from here we're going to go to from very first beginning to very end, and we'll understand each and every topics one by one in very details. So first topic is going to be big O notations. So what you're going to study about here is like what is data structures, what are the linear data structures, non-linear data structures, common data structure operations, abstract data types, what is an algorithm and how to analyze this an algorithm, what are the two basic things there in algorithm, that is time complexity and space complexity. We're going to learn about those things and asymptotic notations, and we're going to solve tons of problems here. So let's move forward. So when we say data structures, so basically data structure means nothing. This is just way of organizing data and storing data in memory. So that's how it goes. So it helps to access and manipulate the data more efficient and effectively. So in whichever company you see, every company is using data structure in some way or the others. So if you see here, linear data structure and non-linear data structure, you'll understand by these things what does, what I say by node, what are, how they are connected to each other, and how we are defining these are linear data structure and those are non-linear data structures. So if you see this diagram, then here you can understand that data structure, if you're calling the whole structure as a data structure, then inside that linear data structure will be coming, and in that non-linear data structure will be coming. So when we say linear data structure, array, stacks, queues, linked lists, those things will be coming out there. And when we say non-linear data structure, trees and graphs. So if you have any query right now about what is linear data structure and non-linear data structure, don't get confused, because we'll understand each thing one by one. Moving forward to the linear data structures. So arrangement of elements in a sequential or linear fashion or in a single line fashion, that is called linear data structure. So each statement is attached to its previous and next adjacent element. So we can say this as element or as node. So one node is connected to the other node, and they're in a single line. So that is what linear data structure is. So in linear data structure, we can further divide into two parts, that is static data structure and dynamic data structure. So when we say about static data structure, it has fixed memory. So if we take example, then array is one of those. So you'll understand whenever I declare normal array, there you'll understand that is static memory allocation. So and if I don't write anything, I say dynamically, we can create array dynamically also. If I don't say anything, it means we are allocating in static memory allocations only. So we can allocate array in dynamic memory allocation. So that is also we're going to see. Next thing is dynamic data structure. So what are those dynamic data structure is that basically you can change the size of dynamically in at runtime. Suppose you are running some code and you want to change the size of that, whichever container it is storing, either be it array or linked list or something, anything else, and you want to you want to change the size of that, element. So that time we'll be using dynamic memory allocation. Those are dynamic data structures. Basically dynamic data structures are very efficient in memory as compared to the static data structure. So if I say examples of dynamic data structures, that is going to be stacks, queues, linked lists are the examples of dynamic data structures. Moving forward, next, the elements present at the same level, which allows traversing in the single run, and time complexity increases as data size increases. This is also there, right? So working well mainly in the development of application software.
Now we'll move to the next topic, that is nonlinear data structures. So in this nonlinear data structure, we're going to learn about like what are the types of data structure there which are nonlinear, and what does this nonlinear data structure means. So first thing first, that arrange the elements in non-sequential order, that is a hierarchical order. That is what nonlinear data structure is. So one more thing there in nonlinear data structure is that here multiple nodes will be connected to each other. So when I talk about nonlinear data structure, then examples we can see that trees, graphs, table sets, these all are non-linear data structures. So the elements present at various levels, so you can't traverse them in single run. So that is the basic definition of nonlinear data structure. So time complexity will remain the same in non-linear data structure. And one more thing to talk about here is like it works well in the process of image processing and artificial intelligence. Then if we talk about the advantages of data structure and algorithm is it is totally language independent. It means you can learn for Java, Python, C++, C#, any language you want to learn with. Second thing is DSA is basically improves logic building. DSA is just nothing, it's just problem solving things. So it improves problem solving approaches, it enables to solve real world problems, help in writing optimized code and adaptability to emerging stack. And it helps to get job in big MNCs like Microsoft, Apple, Google, Facebook and all companies. Basically each and every companies use data structure and algorithm very vastly. So if you know that Google Map is there, they're using graph, and if you know that Spotify they're using linked list or something, some kind of data structures, because of those they are able to process the data very fast. Next thing we're going to learn that is common data operations. So when we learn data structure and algorithm, then what are going to the operations and that? So we're going to learn about insertion, deletion, searching, sorting, traversals, merging. So we're going to talk each thing one by one. So when I say insertion, it means we're going to insert element in the data structure. So data structure will get changed one by one. Sometimes we'll be learning about arrays, then linked lists, trees, graphs, and all other data structures there. Similarly, deletion will be there. So we want to get out of that element from that data structure, then they will remove that element. That is what deletion will mean. Next thing we're going to see is searching. Like suppose we want to find a number in an array or in a linked list or some other data structures, then we can able to do it also with that searching algorithms. So there are various types of searching algorithms. I'm going to teach you about, binary search, linear search, and BFS, DFS, and all these things I'll teach one by one. Next thing we're going to learn is sorting. So for sorting, we're going to learn lots of data structures, not data structures, algorithms here also. Lots of sorting algorithms here. We're going to learn those things. Next thing is what? Traversals. So traversals are just nothing, just getting through all the elements. That is what traversals means. Then we're going to learn about merging, that combining two similar data structure together is going to be the merging. So we're going to learn one by one each everything. So what is abstract data types? So abstract data types are the data structure that defines the declaration of data and operations, but not how these operations are implemented. So if I take examples of abstract data types, those are array, linked list, stack, queue, binary tree, graph, etc. These are all abstract data types. The implementation of abstract data type will be decided based on programming language you are using. Now question arises is what is an algorithm? So till now we have seen like what are the different data structures are there and all those things, what are the operations we're going to apply and everything. Now first question arrive is like what is algorithm then? So algorithm is a step-by-step procedure to solve a given problem. That is what algorithm mean. So there are two main criteria to judge an algorithm. So those two main criteria to analyze an algorithm are effectiveness and efficiency. What do you mean by effectiveness? So in how many steps you're going to take, you're going to get that desired result. That is what effectiveness. And Efficiency is how much time and memory you're going to take. That is what efficiency is. So we're going to learn about, you know, big O notations and all those things after few lectures. So there you'll understand how we are implementing those things. An algorithm which takes minimum steps to produce the desired result is considered to be most effective, and that algorithm need to be correct. That you have to keep in mind every time. An algorithm which takes the minimum time and less space to execute is considered most efficient. Why it is so? Because it will cost less money to the companies. So that's why data structure algorithm is very necessary to be efficient. So if I talk about that, what will be the algorithm for adding two numbers? Then you'll say that we'll start and we'll declare two variables, and basically we'll declare three variables. We'll store first variable in num1, we'll store second variable in num2, and we'll store the values in some variable. Then we'll read the values of num1 and num2, and fourth step will be add the values of num1 and num2 and assign it to sum. So that is what the basic steps is. So this is very basic algorithm, but we'll deep dive into complex algorithms and we'll understand each and everything in very easy words. Now if we talk about algorithm analysis, then analysis of algorithm helps to determine the time and space consumption to execute it. So it is very necessary that whatever the code you are writing, that need to take less space and less time. That will be our goal every time. So that is also called efficient code and optimized code. So it helps to predict the behavior of an algorithm without implementing it on a specific computer. So when we talk about the three analysis we do, that we say is worst case, best case, and average case. So worst case is which one? The maximum time to execute. And best case is that case where it take minimum time to execute. And average case is going to take, you know, a prediction time to execute. So these are all algorithm analysis cases with that. So when we say asymptotic analysis, there we try to understand how much time it is going to take. So asymptotic analysis is way of understanding how algorithm behaves or performs with a change in the input size. For example, if we talk in bubble sort, when the input array is in the reverse order, the algorithm takes maximum time. That is quadratic. To sort the element, that is the worst case basically. But when the input is already sorted, the time taken by the algorithm is linear. That is the best case. So we'll understand this quadratic linear, what does this means? We'll understand by graph one by one. So no need to worry about right now. So when we talk about the input array is neither sorted not in reverse order, then it takes average time. So we're going to categorize every kind of each and every algorithm by worst case, base case, or average case. And we'll try to achieve as much as optimized code. We'll try to achieve that. So we'll end it here, and after we'll go to the VS Code, and there we'll understand each and everything in very detail.